So here are the answers to the questions at the end of the previous chapter. Hopefully you've got all these right. So why don't you tick these off before we go on to how do we design objects to manage the transfer of energy? So how are vacuum flasks designed to reduce the transfer of energy to the surroundings? Well, we put our drinks into the double-walled glass container in the middle. It's double-walled, and between the walls there's a vacuum. There's no air. And the reason is because the vacuum reduces heat loss by conduction and convection. If there are no air particles, then there's no medium to allow conduction and convection. And also the inside surfaces are covered with a silvery coating because silvery surfaces reduce radiation. The plastic cap is made of plastic because plastic's a poor conductor. And when you think about it, when you put a lid on anything, if it stops evaporation, it'll reduce energy transfer by evaporation. A radiator. Now the whole purpose of a radiator is to transfer energy to the surroundings. That's the point of it. We find them in vehicles to prevent overheating of the engine. We also find them in homes to transfer energy to the rooms to heat them up. And they're designed to have many fins which increase the surface area for energy transfer. The energy is transferred through the walls by conduction, and this means that the surrounding air is heated, and this transfers energy to the room by convection, and the room is heated directly due to infrared radiation. Here you go, radiator. Now, what are heat sinks? Well, these are needed to keep electronic components cool. They're metal plates which are designed with many fins to increase the surface area, and they're attached to the electronic component. For example, they'll be attached to the back of a computer or a television, and they transfer energy from the component to the surroundings. The idea is they help the component to lose heat and prevent overheating. Electric storage heaters. Now the idea of these is that they use sometimes cheaper off-peak electricity at night to heat up. They heat up slowly, and then during the day they cool down. They transfer their energy slowly to the room. And you can see inside they contain concrete bricks which have a heating element going through them. The concrete bricks heat up slowly, and then when the electricity is switched off, they slowly transfer their energy to the room. Okay, so quickly test yourself. Hopefully you've printed out all these notes so you can answer it now and find the answers at the beginning of the next chapter.